Hey everybody, Matt here. Thanks for stopping by and welcome to Imagine Then Make. In my last video, I started talking to you about prototyping, a subject that's near and dear to my heart. In this video, I want to continue talking about prototyping. In my last video, where I first started talking to you about prototyping, I described these wooden covers that I came up with, the ones with the magnets. If you missed that video, I'll leave a link in the video description so you can check that out. So in this video, I want to talk about two different things. First off, it was quite a while ago that I did a video where I prototyped a small-scale wooden table that would fold up flat so it could lean against a wall for easy storage. And it was intended to be an outfeed table for a table saw. That was the original thought. So if you missed that video, I will leave a link in the video description so you can check that out. To me, that video just shows kind of starting from scratch, no drawings, just kind of an idea. And then working with some parts, trying different things, very much trial and error with actual small pieces of wood and some nuts and screws until I finally came up with what I wanted, what met my design criteria. So again, I'll leave a link in the video description so you can check that out. To me, that's a pretty good example of the kind of prototyping I really enjoy doing. And finally, in this video, I want to talk to you about another prototyping project I worked on several years ago. Again, this was a problem that was spawned from an issue we had at my workplace at the time. It's kind of a long story, but I'll try and be brief. Okay, back at that job, what I was involved in was the designing and building of robotic welding cells. In other words, a big metal box with a robot inside of it, and it's big. You know, it's the size of a typical bedroom in a three-bedroom house. So picture a bedroom about that size with a robot in the middle of it, okay, doing welding parts, aluminum, steel, galvanized steel, whatever it was, okay? So in case you don't know anything about welding, when welding happens, it gives off very bright light, which can harm your eyes unless you're wearing protective gear. That's why welders wear a welding helmet. This is my welding helmet from back then. I was a robot programmer, but at the time I was also doing some welding with the robots. So when that was happening, I would wear this helmet because the lens here filters out the really harmful UV rays from the welding light so that I could look at the robot while it was welding but not hurt my eyes, okay? And just as another little fun fact, during the last solar eclipse, I happened to be at a customer's location in California, and although I didn't have my welding helmet with me, there were plenty of guys there that had welding helmets, and so we all took turns using welding helmets to actually view the solar eclipse through the lens here, knowing that we could see it but not hurt our eyes. Okay, so this particular problem that I was trying to solve in our robotic cell, we had a door that worked vertically. So the door, when it was fully down and was open, the operator was able to reach inside the booth and install the parts that needed to be welded, and then of course remove himself from inside, push some buttons, and the door would go up. Okay, the problem that I saw was that the door went up, yes, but it didn't go up quite high enough, because if you were a person that was like 6 feet tall, I'm not, but if you were a person that was like 6 feet tall, you could actually see over the top edge of the top door panel, and you could be exposed to some of that welding light, which I didn't think was all that great. So I took that as a problem, sort of off to the side, and I said, well, instead of having a vertical door that just has two panels, the first panel is stationary, and the second panel goes up and down, right? But when it comes down, it has the top surface of the moving panel needs to be at the same height as the fixed panel. So the operator, you wouldn't want the moving door to only open that far, because then the operator would have to reach over it to put parts in or take welded parts out. So we didn't want that. So the problem is that with only two panels, you can't raise the door high enough to really effectively block all the light from anybody that might be in the area. So what I did was, again, because I enjoy this kind of problem solving, I started with a pencil and a piece of paper, and I started making some notes and making some very crude drawings. My idea was to make a door with 3 vertical panels, so that there's a fixed panel right in front, and then the next panel behind it goes up this far, and then there's a third panel behind that one, and that goes up a little further. So it's a 3-tiered door instead of 2. So I thought about all kinds of different ways to kind of work this out mechanically so all the bits and pieces would fit without interfering with themselves. And once I did enough pencil sketching, I moved to a computer, and I'm not sure what I drew this in. I might actually have drawn it in PowerPoint. I don't know if any of you have ever drawn anything using on a PowerPoint slide, but it's actually pretty useful. If you don't have PowerPoint, there's plenty of free PowerPoint work-alike type programs. I use OpenOffice quite a bit, and that has a PowerPoint-like program. And I believe there's also another one called LibreOffice that has a similar sort of functionality. So if you wanted to do some of this stuff at home and you didn't have Microsoft Office on your computer at home, you can go to either OpenOffice or LibreOffice and download their Office suite and start learning about the different applications that are built into the suite. I think they both include an application that's similar to PowerPoint. I think they also both include a drawing application. So if you didn't want to draw with something like PowerPoint, which is a little easier to draw with than, say, a more comprehensive drawing program, then you have that choice. Anyway, so at its height, I actually drew this. So you can see what I'm trying to demonstrate is I started from this kind of stuff, and then over time worked up to this. This happened to be drawn in Visio, I think, which is the application, the drawing application I had access to at my workplace. Okay, so once I got this far and I felt like maybe I had something that would work, I wanted to prototype it in 3D. And this, at this point in time, I hadn't yet discovered SketchUp. So just like with the wooden pieces that I showed you in the previous video, I went right to not wood so much, but I actually started with with some foam core and some folded up pieces of paper and some bent paper clips and some hot glue and even pieces of straw. So my point to all this, at the risk of kind of embarrassing myself, is that I was able to take my idea and put it into something that was semi-real in 3D. Okay, so the way this works is this is the fixed panel. So the operator is out here and the robot's in here. So the operator would reach in, put parts into the fixture, clamp them into position, pull himself out of the booth, and then push some buttons, presumably out here, which would raise first the second panel. Let's see if I can do this. You can tell it's a very crude kind of prototype, but it's kind of a proof of concept kind of thing. So there's the next panel that's raised up, and then after that, I would raise this panel. And it was, all of these pieces were sized so that at this height here, the typical person, I think I designed it for somebody that's like 6'2" or something like that. If they were standing right in front of it, they couldn't see over it enough to actually directly be exposed to the welding light. Okay, so that was kind of the idea. Okay, so again, I kind of enjoy doing this. The other side of this, I actually used straws to simulate pneumatic cylinders, and I kind of put brackets up here to kind of simulate how the cylinders would be held, and some grooves and some tracks to show where these panels, how these panels would slide up and down and so on. So I got this far, but I wanted to keep going, so then I made this one. So this one is made primarily of foam core and hot glue. And you can see there's some pieces of wire here and some straws again to represent the pneumatic cylinders that would be used. And the purpose of this model, kind of the next generation, was to think a little bit more about how the thing would actually physically go together out of pieces of steel. Where would all the fasteners go? How would you access the internal components if you needed to service it, etc., etc. So this is kind of what I came up with. And so this idea calls for a front panel which is removable so that you can reach the inside guts down in here if you needed to service anything. Okay, and this would probably not swing out on a hinge. It'd probably be held on with some screws. But for model or simulation purposes, I just kind of made it swing out. And again, I used a really fancy hinge, a piece of Scotch tape. Okay, so again, like the other version, there are two panels that move. So I'm going to attempt to move them. And again, because this is a crude prototype, you know, it's just kind of for demonstration purposes. So here's the first panel that's moved up, okay, and it goes up about even with here, something like about that. And then the third panel would raise up here, and this, the way I actually constructed this model, this surface was actually taller than the previous one, and I could see how all I would need to do is make all of this taller if I wanted this panel to go even a little bit higher. So So basically, this is what I wanted to show you. So prototyping does not have to be expensive. I guess that's one of the things I'm trying to get across. You can get foam core board from the dollar store, a drinking straw from McDonald's for free, pieces of wire. It could be a coat hanger, it could be a paper clip that you straightened out. Certainly Scotch tape, maybe some hot glue from the craft store. And you can put together pretty quickly some ideas in 3D that will help to kind of determine whether or not your idea has any merit at all. Now, I did this several years ago, and 3D printing was starting to come on board. You could certainly do the same sort of thing doing 3D printing, but for me, if I was to 3D print this, I would have to do drawings of each of the individual parts. And believe me when I tell you, when I put together this foam core model, I was doing a lot of changes. I was doing a lot of cutting and trimming and more glue here and some tape here and a straw in a different position there. I didn't really have a finished design in mind. So to me, this was the most effective way to quickly get some kind of a model that's sort of a proof of concept type prototype. So I hope that makes sense. I hope that encourages you to try your hand at prototyping. It doesn't have to be expensive. You can just use stuff right out of the office supply store to piece together a model that represents your idea. You can make things move, albeit kind of manually, but I believe it'll give you a good opportunity to check out your idea and see if it's worth going the next step, maybe making a scale model out of wood, or maybe even out of metal, or maybe doing some drawings and having it 3D printed, or maybe if you have access to a CNC wood router, you could do some drawings, route out the parts, and put together either a scale model or maybe even a full-size model. So there's lots of possibilities. It's hard to jump to that fabrication technique right away without doing the prototyping, in my opinion. So anyway, that's what I wanted to share with you. I hope it inspires some of you to go to the office supply store and pick up some stuff and go home and throw together some prototypes.